Here we're looking at the displacement reactions of the halogens. So you should have already filled in your prediction sheets. And what we're now going to do is go through and have a look at the different reactions. So what I've done here is I've blown up the results table. And what hopefully is going to work is that we're going to carry out the reactions in each of our conical flasks here and end up with a nice colourful grid of results. So first of all, I'm going to put sodium chloride into all of the back row here. Make sure you can see that I'm doing it there. Then our next row has our potassium bromide. So notice so far we've got two clear colourless solutions. And then our front row has our potassium iodide. Be no great surprise that also a clear colourless solution. So I'm now going to work my way down the first row. So I am going to take chlorine water and put a good squirt or two of chlorine water into each of our salt solutions. Let's put a bit extra in for good measure here. Okay. So, having a look so far, we might be able to record our changes. Going to put a bit more chlorine water. It's quite dilute, so we'll put a bit extra in just to make sure we get as much reaction as possible in order to be able to see a change there. Okay, so you might have started writing down your observations. I will look at each of these in turn shortly as well, so if you're not sure at the moment, we can do that in a minute. So our second row, we are going to put in bromine water, so we can have a look at the colour of the bromine water to start with. I think I'm actually going to pour this rather than use the dropper, make life a little bit easier. So bromine water into our potassium chloride, bromine water into our potassium bromide, and bromine water into our potassium iodide there. So our last one to add is our iodine. I'm going to just pour some of our iodine solution into this test tube so you can see what it's like to start with. And then in a similar way, let's pour some of this in to each of our solutions. Okay, so what we now need to do is go through and make sure we've got our observations down. So in our right hand column here, we've got iodine with sodium chloride and we have an orange solution. We've got iodine with potassium bromide and we've got an orange solution. And we've got iodine with our potassium iodide, also an orange solution. Then we've got bromine in with our sodium chloride. Now it's quite hard to tell with the light here, but this is just a slightly orange solution, so kind of more of a sort of a pale yellow, pale orange there. this one here, actually let me put it on, there we go, that looks more of the colour there. Okay, so that's just showing you more clearly. So that's slightly orangey yellow as well. Let me show you that top one again. And then the bromine with our potassium iodide, that's a distinctly orange solution like that. Then we've got our chlorine with our chloride ions. That's pretty much colourless there. We've got our chlorine with our bromide ions, so with our potassium bromide. If I put it on the white here, now, oops, my hand's missing it going through the camera here. Certainly here it's a very pale yellow. I don't know if you can pick that up, but a very pale yellow compared with the colourless of our other one there. And then finally, if we look at our chlorine with our potassium iodide, we've got our orange again. So let me give you a good view of all of these this way, and additionally over this way as well. Okay, so make sure you've written all your observations down there. Now, the tricky bit about the reactions we've just been looking at is deciding whether the colour is due to the bromine or the iodine. So they can look quite similar depending on the concentrations that you have in water. And to be sure about what's going on in each of these, sometimes we need to do an extra test. So one thing we can do when we have halogens is actually add a different solvent, and they actually appear a different colour in this different solvent. So this is cyclohexane. It's an organic molecule. So its formula is C6H12. And I'm going to add a good amount of this to each of our test tubes here. Now, if you remember from before, our iodine solution was orange. Now, if I dissolve iodine in cyclohexane, we'll have a look in a sec and see what we can see there. We can also do the same with our bromine water. So dissolve bromine in cyclohexane. And we can do the same with our chlorine water. Now I'm going to give each of these a shake, and then we'll have a look carefully at what we can see. Now in each case, the organic solvent is less dense than water. So the upper layer, we'll have a look carefully so you can see what I mean by the upper layer. The upper layer is the organic solvent, and to get the organic layer and the aqueous layer to mix together, we need to give them a really good shake. So it's basically like mixing oil and water. They'll just sit on top of each other. So we need them to tumble together so that the halogen molecule will become dissolved in the organic solvent. Okay, so if we have a look at these now, I'm going to take them out of here so we can see clearly with the white background. If we have a look at these now, so this one on the right hand side is iodine. So the bottom layers are our aqueous layers, the upper layer is our organic solvent. So our iodine was an orange in colour in an aqueous solvent in water, but in the organic solvent is this really distinct purple colour. Our bromine was a pale yellow orange colour in our aqueous solvent, so in water, and is orange in the upper layer. And chlorine, when dissolved in water, is very pale green and is very similar in the upper layer. But we now have three very distinct colours here. So we could then apply this to maybe a reaction where we're not sure what's gone on. So when we put chlorine into bromide ions, we had a very pale yellow colour there. It's kind of hard to see. When we put chlorine into potassium iodide, we had a distinctly orange colour there, so that was much easier to see. So what I'm going to do now is transfer both of these reactions to a test tube. And and we're going to use our organic solvent to help us identify the reaction. And hopefully this will just enable you to see where doing an additional test can be useful. So we put in our organic solvent. All right, we can see the organic layer on top, so the layer on top of our reaction mixture. What we now do is that same, give it a really good shake so the layers are tumbling together, and then we can extract our halogen molecule into, oops, splash everywhere, into the upper layer there. Then I'll leave that to settle down, and then we can do the same here. So we let these settle out, and then hopefully we can see here. So we've definitely got a pink layer in the top, so that's confirming that we had iodine produced in the reaction there. And then over this side, still pale, but I think we can see a more clear orangey colour that's going to help us be sure that we've produced bromine. Piece of paper behind, that sometimes helps as well. Okay, so we can now see that that one is a yellowy colour at the top as opposed to the colours down at the bottom there. So it was very hard to spot that there was any bromine produced in the lower layer. It didn't give it much colour, but it's definitely yellowy in the upper layer. This one, it was fairly yellowy anyway, but the pink in the upper layer confirms the presence of the iodine there.